Okay, this video is going to look at something that you haven't had to deal with. We're going to add or subtract rational expressions. Okay. All right, now, this is the operation you do with rational expressions where you cannot get rid of the denominator, okay? So when you have a problem like, well, before we do number 7, if you had a problem like 1/2 plus 2/5, something like that. When you're adding fractions, that's the operation where you have to get a common denominator, okay? So you need common denominators. Okay. So for this one, 2 times 5 would be the common denominator. That would be what we'd call the least common denominator. All right, now in the video on solving rational equations, I was able to use the least common denominator to cancel out the denominators. But here I don't have an equation, so there's not a way to make that mathematically okay to do because I don't have like 2 sides of an equation, or I can't multiply the top and the bottom of the fraction by the same thing. So you need common denominators, and so what you got to do is use the LCD and rewrite each fraction so that it has that denominator. So you got to rewrite each fraction using the LCD, making the LCD the new denominator, okay? And so notice that I used to have a 2, but I need the denominator to be a 10. So that means I had to multiply the denominator by 5 to make that happen. So I'm going to multiply by 5 on top. So that gives me 5. Okay. All right, now on this other one, I had a 5 and I need a 10. So I'm going to multiply by 2. And if I multiply the bottom by 2, I'm going to multiply the top by 2. That's going to give me a 4. So 5/10 is the equivalent to the original fraction 1/2, and 4/10 is equivalent to the original fraction 2/5. So I'm not really changing the problem. I'm just getting it to where I have like fractions. So it's kind of like, you know how you needed 5x plus 4x to be able to combine them and say 9x? It's like we have 5/10 plus 4/10. So we'll be able to combine them to get 9/10. And then in the next unit, we'll have something like 5 square roots of 2 plus 4 square roots of 2, and those will be like radicals, and we'll say 9 square roots of 2, okay? So having the same denominator is like having like terms in a way. They're just like fractions. So you're able to count up how many tenths you have, okay? Like you used to have like terms, and like later, we need to have like radicals to be able to add them, okay? All right, so now that we have the same denominator, we're able to count up how many tenths we have. We have 5 plus 4, that would be 9 tenths. And then at this point, you would simplify if you could, okay? So that problem was not on the sheet, but let's look at one with some variables in the denominator. So we have 2 over r plus 5 over r minus 9. All right, so we're just adding. We don't have an equation. We can't clear the fractions. So what we're going to do is look for the LCD. That's r times r minus 9. I need the r for this, and I need the r minus 9 for that. Okay. Remember, this is like r minus 9 all together. So you can't separate the r and the 9. All right, so my LCD is going to be r times r minus 9. That's what I want my new denominator to be. I want it to be r times r minus 9 on both of these. Okay, so what I do is I notice that I already had the r here. So I had to multiply by r minus 9. So if I multiply down here by r minus 9, I need to multiply up here by r minus 9. Because then I'm not really changing the size of the fraction, I'm just changing its name. Okay, so here I would have 2 times r minus 9. Actually, I'm going to show you what you really would probably want to go ahead and do, because one of the hardest things about these problems is they feel like they take too much paper. So really, I go ahead and distribute at that point. I would write down 2r minus 18 rather than 2 times r minus 9. All right, now on this side, notice that I already have the r minus 9. So what I need to multiply by is r. And if I multiply down here by r, I got to multiply up here by r. Okay, so that's going to become 5r. This one happens to have a plus. Minuses are harder, but this one just happened to be a plus. So now what I've got is 2r minus 18 plus 5r all over r times r minus 9. Once you get a common denominator, then all you do is add or subtract the numerator. Okay, whatever it says. This one said add. All right, now while you're doing that, if it makes sense to you, you could have gone ahead and combined your like terms. If you didn't do it earlier, that would become 7r. So we have 7r minus 18 over r times r minus 9. Okay, and remember, you can't just knock out the r because of that minus right there. R is not a factor. You can't write the numerator as r times something. Okay, so you have to just stop at that point. That's fully simplified. All right, so that's the gist of it. That's the basics of it. All right, and it can get way worse or it could be easier. Okay, so let's go ahead and look at number 8. All right, on number 8, I have m squared minus 6m over m minus 4 plus 8 over m minus 4. Oh, so this one already has common denominators. So the LCD is m minus 4, so I don't need to go find it. I already have it. Okay, so what I'm ready to do is to go ahead and get the numerator written. So that's going to be m squared minus 6m plus 8 all over m minus 4. Okay. So that's going to be basically it, except I wonder if this can be simplified. So I'm going to see by seeing if I can factor m squared minus 6m plus 8. So that's all I'm doing now, is looking to see if I can simplify. Okay, sorry, let me turn that off. So I'm going to do m minus 4 times m minus 2. I think that's going to work. Negative 4m, negative 2m would give me what I need, and the negative 4 times the negative 2 would be 8. All right, so this one actually has a common factor top and bottom, and so it winds up being just m minus 2 at the end. Okay, that would be your final answer on that one. All right, so that one didn't have the hard part of trying to get both fractions written using a common denominator. It already had it. All right, let's try one like, let me skip number 9 for just a minute. Let's look at number 10. All right, number 10 is kind of like the earlier one, except because this is x plus 4 and this denominator is x minus 4, the denominators are not the same. Okay. All right, so on this one, your LCD would be x plus 4 together with x minus 4. X plus 4 times x minus 4. You'd have to have both of those. Okay, you'd have to have both of those. Okay, so now what I've got to do is I've got to try to rewrite the first fraction so it uses that denominator, and the second fraction so it has that denominator. So this is different from the problem that had an equation, because if it had an equation, I could clear the fractions, but I can't do that here. Okay. All right, so now, do you notice how I already have the x plus 4? So what I need right here is an x minus 4. And if I put that on the bottom, I need to multiply the top by that. Otherwise, I'm kind of just arbitrarily changing the problem. Right? And then look at the second fraction. I already have the x minus 4. What I need is the x plus 4. And if I multiply the denominator by x plus 4, I got to multiply the numerator by x plus 4. Okay. Then I think it works good to go ahead and distribute. So that would be 5x squared minus 20x. There's a plus sign here. Then this is 2x plus 8. I have a common denominator, so that means I'm ready to just add or subtract the numerators. So that's 5x squared. And if you notice like terms like negative 20x and a positive 2x, it's nice to go ahead and put those together so this doesn't drag out to be a whole couple of pages. So we get 5x squared minus 18x plus 8 with this denominator. Okay, now you can leave your problems in factored form and it's still considered fully simplified. It actually helps to have them in factored form. So one thing we got to check is whether there's anything I can cancel out from the top and the bottom. And I can't tell until I factor that numerator, or try to at least. But here's the thing. I don't really care whether it factors unless it factors so it has either the x minus 4 or the x plus 4. Then I would have to cancel out a common factor. So you don't have to just kill yourself to try to get this thing factored. All you need to check on is whether there's a way to break it up. Here's a 5x and an x. Whether there's a way to break it up so that you have an x plus 4 or an x minus 4. So that's how it would have to factor. 4 times 2 would be 8. 5x times x would be 5x squared. This looks like it could potentially work. See how there's a 20x right there? And then this would be a 2x. So it seems like I could get it to work if I could put a negative in front of the 4. So I would get a negative 20x. But then I'd need a positive in front of the 2. And it actually doesn't work because that would make it a negative 8, and I needed a positive 8. And putting a plus here doesn't fix it because that would make it 22, and I need a negative 18x. So this did not factor so that I could cancel out either x plus 4 or x minus 4. So I don't need to look to see if it would factor in any other way, because the only thing I'm looking for is whether there's something I can cancel out on the top and the bottom, and there wasn't. So I don't need to keep on trying to factor. If I can't get it to be x plus or x minus 4, I'm done. I'm not going to try anymore. And then this would be my final answer. All right, so that's number 10. All right, let's try another one like that. Okay, problems are harder if you don't try to make sense of them, if you're just trying to like randomly follow the steps. So really try to make sense of them as we go. And at this point in the semester, it can be a challenge if you haven't really been working from the beginning to where you've understood things as we go. It's hard to go back and make sure the factoring is good and that kind of thing. But you can get better at it. You just really have to work hard to try to understand. All right, so let's look at this. So here we're just subtracting these two fractions. They don't have a common denominator. I need the LCD. Okay, so what I'm going to wind up doing is factoring. Here, I'm going to factor to try to get my least common denominator. I can't tell unless I get this factored. All right, so once I factor that, I'm noticing that I would need an x plus 4 for the first fraction, and then if I just throw an x plus 1 in there, then I have the x plus 4 times the x plus 1 that I would need on the second fraction. So this is my LCD. I don't need to have two x plus 4s in there. Okay? I just need to be sure I can find both of these denominators. And I can. Here's the x plus 4, and then the whole thing would be the x plus 4, x plus 1. So the LCD is just 1x plus 4 and 1x plus 1. All right, now you can't clear the fractions. You're just adding and subtracting them. You don't have an equation like we did earlier. So what you need is to get the fractions to have the same denominators. Okay, well, The second one already does, doesn't it? So there's nothing I need to do to it. It already has the denominator I needed, okay? But the first one, we have the x plus 4. What we're going to need to put with that is x plus 1. We already have this, so we need that x plus 1. So we already have that. This needs to be multiplied to make the new denominator. And so if I did that on the bottom, I've got to do that on the top. All right, so now let's go ahead and distribute. That would be x squared plus x. Okay, I've got a common denominator, so I'm ready to go ahead and write that as one fraction. I'm going to take and add or subtract the numerator. So that would be x squared plus x minus 6. Okay. All right, now, I don't really care whether the top one factors. What I care about is whether it factors so that one of the factors is either x plus 4 or x plus 1, because I'm looking to see if I can simplify this. But see, that numerator, if I were to factor it, it would factor, but it would factor into x plus 3 and x minus 2. That would wind up multiplying to equal the x squared plus x minus 6. Okay? So there isn't any kind of a common factor, so there's nothing you need to cancel out at that point. So you can leave your answer, if you did that, you can leave your answer in the factored form. Okay? Or you can leave your answer like that, since the numerator didn't break down to where you could cancel out a common factor. This is okay too. Okay? All right, you'll probably normally see it that way. Okay, so that's problem number 11. All right, and let's see, I skipped number 9. Number 9 has an issue that I want to get at. See how number 9 has a denominator over here that's 2x minus 3, and then a denominator over here that's 3 minus 2x. Those have kind of an unusual relationship, okay? The relationship between those two is kind of like having a 7 and a negative 7, okay? Here's what I mean. All right, if you had 7 and you took its opposite, negative 7, if you were to add them, you'd get 0, wouldn't you? Okay, they're opposites. These are opposites. Okay, well, it turns out that 2x minus 3 and 3 minus 2x are opposites. Okay, I can tell that because see how the 2x over here is positive and the 2x over here is negative? And see how the 3 over here is negative, but the 3 over here is positive? So the signs have been changed. Like if I took 2x minus 3 and I changed the signs, I'd have this one. So they're opposites. You can also tell they're opposites if you let x be some number. Like, let me let x equal, I'm just picking a random number. Let me let x be, actually, let me let x be 5. See how this would be 2 times 5 minus 3. This would be 3 minus 2 times 5. See how this would be 7, but this would be negative 7. And it doesn't just happen like that for 5. No matter what I plug in for the x here and here, I'd get two numbers that are opposites of one another, no matter what I tried, okay? All right, so when that's the case, then the LCD really just needs to be one of these two because they're basically the same. It's just they differ by -1, okay? One of them's just -1 times the other. So what I'm going to do, and you'll notice that if you ever just see numbers that appear to be the same, you can look and see if they're really opposites. If they are, what you can do is just multiply by -1 on the top and bottom of one of them. So I can leave this 3 over 2x minus 3. I'm going to leave this alone for now. That would be -9. And see that negative, when I distribute it, would be -3 plus 2x. Now, I know it still looks different than 2x minus 3, but it really isn't, is it? Because I have two things. There's a plus. It doesn't matter whether you add that order or this order, okay? Those say the same thing. So 2x is positive and the 3 is negative. Isn't that really just negative 9 over 2x minus 3 now? Okay, so that one I put in there just so I could complete the story. I don't think I'll give you anything like that on the test, but I just wanted you to know if things were opposites, then you don't have to use both 2x minus 3 and 3 minus 2x as your least common denominator. You can just multiply the top and the bottom by negative 1 to create matching denominators. Then you would just add or subtract the numerator. So that would be 3 minus negative 9 over 2x minus 3. That would turn into 12 over 2x minus 3. And you can't simplify that, so you'd be finished. Okay. Now, these are not opposites. Sometimes people mess this up. Okay. X plus 4 and x minus 4. Those are not opposites. Like if I let x be 5, 5 plus 4 is 9, 5 minus 4 is 1. See how they're not opposites? Not opposites. So it's not okay just to have one positive and one negative. See how the x's are both positive out in front. That's why those weren't opposites. Okay? So you don't use that trick when you don't really, it's not a trick, but you can't use that idea. If the denominators were x plus 4 and x minus 4 like they were on number 10 up here, okay, where I had an x plus 4 and an x minus 4, I had to get a common denominator. I had to use both of those for my least common denominator. They weren't opposites, okay? One more comment on opposites. If one was x minus 4 and the other was 4 minus x, those are opposites. They would be opposite in value no matter what you plugged in for x. If you put a 10 in here, you'd get 6. Put a 10 in there, you'd get negative 6. And that would be true no matter what you plugged in, okay? All right, so adding and subtracting, I put 5 of those on there, didn't I? 1, 2, 3, 4, yeah, because that's the most labor intensive. Adding fractions or subtracting fractions is the hardest of all operations to do, okay? So wanted to show you plenty of those.